Welcome to my channel and thanks for stopping by. In my YouTube channel, I have published a video that demonstrated how to perform ANCOVA in SPSS. But based on reviews, some of my subscribers in the manufacturing industries have requested to learn how ANCOVA can be applied to make better decisions in production of materials in the industries. I took a deep consideration of the request and I have decided to produce this video. So in this video, I will be demonstrating how to apply the principles of ANCOVA analysis to the manufacturing industries for a better decision making. My name is Titocan and this is Titocan Solutions, a YouTube channel for improving the knowledge of how to do things. But before I go into the demonstrations, let me quickly give you the synopsis. Analysis of covariance, or simply put, ANCOVA is a statistical technique that combines the features of ANOVA and regression. It is used to compare the means of dependent variable across different groups while controlling for the effect of one or more continuous covariates. Covariates are variables that could influence the dependent variable. You may understand this covariate influence better when you consider the use or the efficiency of an air conditioner in your room when the atmosphere outside your room is warm or cold. So if the air outside is cold, the output inside your room will be high. And if the air outside is warm, the output inside your room will be low. So you can see that there is something influencing the efficiency of the air conditioner. So in manufacturing industries, influencing factors in the line of production exist and are put into considerations in order to actualize higher quality outputs. This is where analysis of covariance comes into play in the line of production. But basically, ANCOVA is used by researchers and production managers to assess whether significant differences exist between group means after accounting for variability explained by the covariates. So statistically, what you look out for is the significant differences in the output or produced item. Being a good application to manufacturing industries, ANCOVA helps to evaluate the effect of different production methods, processes, or conditions on product quality while controlling for other influencing factors, which are the covariates, such as temperature, machine age, or production speed. By adjusting for covariates, ANCOVA enables manufacturers to make more accurate comparisons across different methods or conditions and make data-driven decisions for process optimization. Now, let's take a look at a practical scenario. Suppose a manufacturing company named TMST is testing two different welding methods, such as method A and method B, to determine which produces higher quality metal joints. The company suspects that the temperature at which welding occurs might affect the quality, so the company wants to control for temperature in the analysis. They collected data on product quality scores for each welding method, along with temperature at the time of welding. At the end of the welding exercise, the data collected includes 30 cases, with quality scores as the dependent variable, which is a continuous or scale variable, method as the independent variable, which is a nominal variable, and temperature as the covariate, which is another continuous or scale variable. Now, the production manager wants to compare the effect of two production methods on the product quality score, controlling for temperature to determine whether there are differences between the two methods applied under the influence of the temperature covariate. And if there are differences, are they statistically significantly different under the covariate influence? This is where the statistical analysis of ANCOVA comes in. One of the best tools to carry out such statistical analysis is SPSS. Now, let's go into SPSS to perform the analysis of covariate using this data. As you can see, the data has already been loaded into SPSS. If you don't know how to load data into SPSS, please kindly visit Titocan Solutions YouTube channel to see my video on Introduction to SPSS Software for Beginners, Part 1. In that video, you will learn how to load data into SPSS and how to define the properties of the variables. The link is given in the description section of this video. However, it is important that you have the basic knowledge of how to perform analysis of covariance in SPSS. in case you don't know, please kindly visit Titocan Solutions YouTube again to see my video titled The Best ANCOVA Analysis Procedure in SPSS. In that video, you will see the general uses of ANCOVA, the basic procedure in SPSS, and the interpretation of the results. The link is also given in the description section of this video. But before performing the analysis, let's establish the production hypothesis. The null hypothesis states that there is no significant difference in product quality between production method A and production method B after controlling for temperature, while the alternate hypothesis states that there is significant difference in product quality between product method A and product method B after controlling for temperature. Now, go to the menu bar and click on Analyze. From the sub-menu, put your cursor on General Linear Model, and from the drop-down options, click on Univariate to open the Univariate dialog box. As you can see, your variables are in the box on the left. Now, click on the variable Quality Scores to select it, and then click on this transfer arrow key to move it to the dependent variable box on the upper right. Again, click on the method to select it, and then click on this transfer arrow key to move it to the fixed factor box. Again, click on the temperature to select it, and then click on this transfer arrow key to move it to the covariance box. These are the variables required to perform ANCOVA, and the boxes in which they have been entered are the appropriate boxes. Please take note of this useful information. Now, click on Model button to open the Univariate Model dialog box. In this dialog box, the first thing you should do is to specify the type of model you want to apply between the full factorial model, which is the default selection, and the custom model. But for quality assessment, manufacturing, and production, it is important to determine how the covariate influences the method of production. So, for the sake of this tutorial, go ahead and check the radio button for custom to activate the factors, covariates, and model boxes. Now, you will have to transfer the method and the temperature variables from the factors and covariate box to the model box one by one and together. That is, click to select the method and then click on this arrow key to transfer it to the model box. Similarly, click to select temperature and click on this arrow key to transfer it to the model box. Then click to select method and hold down the control key and then select temperature. Then click on this arrow key to transfer them as interaction variable to the model box. However, you must ensure that the selected option for model type of building terms is interaction, which is why we transfer the method and temperature together. Also, ensure that the selected option for the sum of square is type 3, which is the feature that informs the SPSS system that a regression model is required. Then ensure that the box for include intercept in model is checked by default. If in your SPSS package this box is not checked by default, please go ahead now and check it to complete the model evaluation. Now go ahead and click Continue to close this dialog box. There are no indispensable required actions to take in the contrast, plots, and save dialog boxes. So go straight and click to open the Options dialog box. In this dialog box, select Overall and Model and click on this arrow key to transfer them to the Display Means for box. Check the box for Compare Main Effects, and for the confidence interval adjustment, click the drop-down button and select the Befferoni option to determine the confidence interval. Then come down to the Display section. Check the box for Descriptive Statistics to calculate the mean and standard deviation. Check the box for Estimates of Effect Size to give the percentage variances explained. And check the box for Homogeneity Test to enable us identify if the error variance of the dependent variable is equal across groups. Ensure that the significance level is 0.05. Go ahead and click Continue to close this dialog box. Now, finally, Go ahead and click Run to process the inputs and produce the results of ANCOVA in the output window. As you can see, the results have been produced. But for the application of ANCOVA to decision-making in the manufacturing industries, the following tables should only be considered. 1. Levene's test of equality of error variances, and 2. Test of between subject effects. You can see my video on interpretation of ANCOVA results in SPSS to learn how to interpret the entire result output. The link is given in the description section of this video. Now, one of the most important assumptions of ANCOVA is the assumption that there should be equal variances across the group. The table of Levene's test of equality of error variances provides the results information that helps determine whether there is equal variance across the group or not, making you avoid committing type 1 or type 2 error. The only indicator in this table is the p-value designated as SIG. So if the p-value is less than 0.05, then it will mean that the assumption is violated, indicating there is no equal variances across the group. But if the p-value is greater than 0.05, then it will mean that the assumption is not violated, meaning there is equal variances across the group. But as you can see in this table, the p-value is 0.342, which is definitely greater than 0.05, indicating the presence of equal variances across the group, suggesting that the data used for this analysis is valid. Now let's proceed to interpret the results of the test of between subject effects. This is the most important result table in this analysis. In this table, look at the p-value designated as SIG for method to determine if there is statistically significant difference in quality score between method A and method B after controlling for the temperature. Accordingly, if the p-value is less than 0.05, it indicates a significant difference between the two methods of production, allowing TMST industries to make decisions on which welding method yields higher quality joints. But if the p-value is greater than 0.05, it means there is no significant difference between the two methods of production. This will mean any method of production chosen will yield the same quality joints. But as you can see in this table, the p-value of method is 0.055, which is relatively higher than 0.05. This means that there is no significant difference between two methods of production. That is, as a manufacturing company, still welding can be done using any chosen method between method A and method B, and the same quality output will still be achieved provided the covariate temperature is controlled. But if the analysis has shown a significant difference between the methods, the manufacturing company would have confidently selected the method that produces higher quality scores adjusted for temperature, leading to more consistent product quality and potentially lower production costs over time. This is how to apply ANCOVA analysis to decision-making in the manufacturing industries for best quality scores, and I hope you'll be able to replicate these procedures. But right now, we have come to the end of this video. If you like this video and you want to see more video content like this, please like this video by giving it a thumbs up, share this video, and subscribe to my YouTube channel to receive notification every time I publish new and useful content. Subscription is free. If you have any question, please leave it in the comment section. Thanks for your time and subscription. Thanks for liking this video, and I hope to see you again in my next video. Bye.